Exercise 11.5 and question number 16. Starting with an equilateral triangle, a coach snowflake pattern can be constructed using the following steps. Step 1. Divide each line segment into 3 equal segments. Step 2. Draw an equilateral triangle pointing outwards, which has the middle segment from step 1 as its base. Remove the line segments that were used as the base of the equilateral triangle in step 2. So if we see, these are the patterns. Pattern 1 is an equilateral triangle, and then if we see here, the pattern 2 is exactly made due to the above 3 steps given: step 1, step 2, step 3. So how, if we see from here, so now we can see that the pattern 2 is made up of, again, 3 triangles add up to the previous pattern. How? If you see these 3 triangles, this one, and this one. Okay, so if we color to this triangle like this one, so these 3 triangles, which I am showing you by drawing the lines with black. So these triangles are, we can use this black color to show this. The black color is here. So now this is black color, black color. So these 3 equilateral triangles are being added, and the length of each black equilateral triangle is 1/3 of this white triangle. And then the same thing is done for the pattern 2, which is coming as a result of pattern 3 in the next one, and then so on. So now in part A, we have to find in terms of x expressions for the perimeter of each pattern 1, 2, 3, and 4, and explain why this progression for the perimeter of the snowflake diverges to infinity. So we do part A at first. So in part A, we have to find the expressions for the perimeter of patterns 1, 2, 3, and 4. Keep in mind that the triangle, equilateral triangle, which is white, this is pattern 1. The triangle, the red triangles, including white triangle, is pattern 2. And now finally for pattern 3, black triangles, including the red and white triangles, is pattern 3. Pattern 4 is very difficult to draw, so that is why I have left that one. So but we can initiate for the question from these 3 patterns. So this diagram is basically a mixture of a combination of pattern 1, pattern 2, and pattern 3. Okay, so we find the perimeter of the first one, which is the triangle, white equilateral triangle. Okay, so now the pattern 1 perimeter should be pattern 1, the perimeter of pattern 1, perimeter of pattern 1, because the white equilateral triangle, each side is having a length of x. So x plus x plus x will be 3x. Now, if we go for the perimeter of pattern 2. Pattern 2. So pattern 2, if you see here, from here, pattern 2 is white triangle plus white triangles. So the perimeter will be the external boundary of this pattern. So that will be, I use here this one. So the perimeter will be this, this, and this. So you can go through with this pink line which I have been. Okay, so this is the pattern. Okay, so now each length is of each length is of 1/3 of the white triangle. It means each length is of 1/1/3 of the white triangle, which is x. So how many sides are we observing here? So 1, 2, 3. I show this here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So times it by 12. Okay. So this will be, yes. So this one 12. So the answer will be 4x. Now in the same way, we go for the pattern 3, the perimeter of pattern 3. So how many sides are there? So each of the side of pattern 3 is 1/3 of the previous triangle, which was the red one. The red equilateral triangle has length 1/3x. So 1/3 of 1/3x will be 1/9. 1/9. So how many 1/9x lengths are there in pattern 3? So if you start from here, if I start from here, this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, and 48 finally. Okay, so 48 lengths are there. So what should we do here? We will times this 1/9x by 48. So this will be 16/3x. Okay, so now as I told you earlier that I cannot draw the pattern 4 here, that will be very difficult and time consuming as well. So we will deduce here. If you see the pattern, so this is the first pattern, the number is 3. The second pattern, that is 4 times, and then 4 times of 12 is 48. So 4 times of 48 will be I show here the working 48 times 4. This should be this, but here we will not write here 1/9. 1/3 of 1/9 should come here, so that will be 1/27x. Okay, so if we calculate this, the final number comes in a fraction which is 64/9x. So this is the answer for part A, in which we were required to show the expressions for the perimeter of pattern 1, pattern 2, pattern 3, and pattern 4. So in part B, we have to show that the area of each pattern is this. The area of each pattern means pattern 1 should be here. The area of pattern 1 should be under root 3x square upon 4. Area of pattern 2 should be under root 3x square upon 4, and this, and then 3 will be this, and then 4 will be this. This is what we have to prove. So that is why I'm not writing these whole lines for pattern 1, 2, and 3, and 4. uh, in the whiteboard. So we have to prove this, we have to calculate this and show this. So I think that is okay with that. For area of pattern 1, we need to find the area of this triangle. Which triangle? The white triangle. So I am making here a triangle just to keep it separate from the original pattern. Okay. And then so each length is x, and this will be x upon 2. So we have to find the height, because finally we have to find the area of the pattern. So height will be equal to, using Pythagoras theorem, uh, x square minus x upon 2 whole square, which will be equal to x square minus x square upon 4, which will be equal to x square minus this will be 4x square minus x square upon 4. This should be a longer one. Then x is equal to h equal to root 3 x upon 2. So this is the height of the triangle we have found. Now the area of the triangle, equilateral triangle. Which equilateral triangle? The white one. Area of equilateral triangle will be equal to half into base, base is x, into height, height is this one, root 3 upon 2 x. So area of the triangle, or we can say the pattern 1, is root 3 x square upon 4. Now area of pattern 2, we will take which triangle? We will take the right equilateral triangle, which is the red. Okay. So now we know that the length of each side of the red equilateral triangle is 1/3 of the length of white equilateral triangle. So that is why the length is here x upon 3, x upon 3, and this is also x upon 3. So half of the length will be x upon 6, and we have to find the height to find its area. So area will be equal to, height will be equal to, using Pythagoras theorem, x upon 3 whole square minus x upon 6 whole square will be equal to x square upon 9 minus x square upon 36, which will be equal to 4x square upon 36 minus x square upon 36, which will be equal to root 3 x upon 6. The square root of 36 will be 6. Okay, so now area of one red triangle will be half base. What is the base? X upon 3 into height. Height is under root 3 x upon 6. So the this is coming as under root 3 x square upon 6 3s are 18 to the 36. But one thing that we have to show this as a multiple of the pattern 1, which is under root 3 x square upon 4. So, and we have to show that the length used here is 1/3 of the white triangle. So that is why what we will do here, we will do here like this, and then x will become, if I write here x, this will be x square, but x has been used here 1/3 of the x, so x upon 3. So if we see this number here, x upon 3 whole square will become x square upon 9. So 9 is already used here. So it means we have to show here 4 to balance it. So this is the equivalent form of under root 3 x square upon 36. Okay, so now how many red triangles are there? Definitely there are 3 red triangles. So the total area of 3 red triangles will be 3 times of the area of one red equilateral triangle. So this will be 3 root 3 x upon 3 whole square whole upon 4. So this is the area of 3 red triangles. So now what will be the area of the pattern 2? So area of the pattern 2 will be the area of white equilateral triangle and then the areas of 3 red equilateral triangle. So that will be basically equal to root 3 x square upon 4 plus 3 under root 3 x upon 3 whole square. So this is the area of pattern 2. This is the area of pattern 2. Now the area of pattern 3 is basically finding the area of red triangles and then not red triangles, the black triangle. So we will find the area of one black equilateral triangle, so which has a length of x upon 9 each side, and this is drawn here. We have to find the height at first. So using the Pythagoras theorem, this will be equal to x upon 9 whole square minus x upon 18 whole square, which will be equal to x square upon 81 minus x square upon 324. So h will be equal to 4x square upon 324 minus x square upon 324. So finally this will become equal to root 3 x upon 18, because the square root of 324 is 18. So this is the height of this triangle. So now the area of this triangle will be equal to area of this triangle is equal to base, and this is the height. Which will become equal to under root 3 x square upon 324. But as a matter of fact, we have to make this as a multiple of under root 3 upon 4 x square, the first pattern. So how do we make it? This will become root 3 upon 4. So this will be 81 and this is x square. So we can write this root 3 upon 4 and this will become x upon 9. So this is the area of one black triangle. Okay, so how many black triangles are there in pattern 3, or you can see, you can observe in the whole pattern how many black triangles are there. So if you count, the black triangles are 12. So there are 12 black triangles. So area of one triangle is here. So area of 12 black equilateral triangles will be equal to 12 times root 3 x upon 9 whole square upon 4. Okay. So this is the areas of black triangle, the total areas of all black equilateral triangles. So now the area of pattern 3 will be equal to, I'm writing here, because pattern 3 includes all the triangles, the white equilateral triangle, then 3 red equilateral triangles, then 12 black equilateral triangles. So this is the area of the first one, x square upon 4 plus 3 root 3 x upon 3 whole square upon 4, then plus 12 root 3 upon 4 x upon 9 whole square. Okay, so here we can reduce the fourth one because that will be also coming in the same way. So I am reducing here the final, the pattern 4, the pattern 4. So what is that pattern? So you can see that here is one triangle, one white triangle, then 3 red triangles, then 12 black triangles. So if we consider any color with that, or the new type of triangle will be in which number? So that will be the multiple of 1 3 are 3, then 1 to 3, and then 3 4 are 12. Okay, 3 times 4. This will be 4 times, so 12 times 4, 48. Triangles will be there. We can write here a multiple of under root 3 upon 4, and definitely here will be 1/3 of the previous, which is 1 upon 9. So 1/3 of the previous is 27, x upon 27 whole square. So this is the pattern. So in the same way, the area of pattern 4 will be equal to, we should write here the pattern 3, basically the whole one, and then we will add, because we are going to deduce this, and I have given you the reason. 3 root 3 on 4 x upon 3 whole square plus 12 root 3 upon 4 x upon 9 whole square plus 48. Why 48? Because 3 after the first one was the original triangle, but after the original triangle there is, we can see in each pattern or in each new triangle the base is not included in that one. So that is why that was 1/3, and then triangle pattern is basically started from the second term. So 3 times 4 will be 12, 12 times 4 will be 48 for the pattern 4. So 48 upon 4 and x upon 27. So this is how we have shown the area of each pattern. Now considering the pattern which was the final pattern of pattern 4, in which the GP is in its form. So now taking common under root 3 upon 4 x square, so this will become 1 plus 3 1 upon 9 plus 12 1 upon 81 and 48 1 upon we can write 27 times 27. So under root 3 upon 4 x square plus 1 plus 1 upon 3 plus 4 upon 27 plus 16 upon 243 and so on. Now, because of the reason the GP inside this bracket is not a GP basically. Why? Because the ratio of first and second term is not equal to the ratio of second and third term. So what we will do, we will simply multiply the external value with 1 and we will keep this value common for rest of the values. So now this will be a GP because the ratio of all preceding to the following terms will be equal to 4 upon will be equal to 4 upon 9. So this ratio will remain same in all following to the preceding value. So root 3 upon 4 x square plus root 3 x square upon 4, and then in the bracket we will apply the sum to infinity formula. So the first term, which is a, is 1 upon 3 upon 1 minus r. So r will be 4 upon 9. So this will be equal to 1 upon 3 multiply the reciprocal of 5 upon 9, which is 9 upon 5. So root 3 x square upon 4 plus root 3 x square upon 4 into 3 upon 5. So this is what we did here. Okay, so the separator is here. So under root 3 x square upon 4 plus 3 upon 20 under root 3 x square. So the LCM will be 20. So 5 root 3 x square plus 3 root 3 x square, which will be equal to 8 root 3 x square upon 20, and which will become finally equal to 2 root 3 x square upon 5. Okay, so now we will consider that the converged area, I write this like this, converged area, converged converged area is equal to A times the original triangle area, equal to the original triangle area. Okay, so if we show this here, okay, and remove this separator from here, so this will be equal to, so converged area is 2 root 3 upon 5 x square is equal to A multiplied by the area of original triangle. What is the area of original triangle? That was under root 3 x square upon 4. Under root 3 x square upon 4. So the value of A should be equal to x square, and x square will be cancelled, under root 3 will be cancelled, A will become equal to 8 upon 5. So this is how we can say that, therefore, I make a separator here. Okay, therefore, the area of snow flag converges to 8 upon 5 times the area of original triangle. And this is what shown.